All right, this is Physics Chapter 2, Practice Problems 6 through 10 Solutions. All right, so you want to check your work and correct your work if you made a mistake. So our first one, number 6, says, in an amusement park, there's a free fall ride that drops riders straight down for 30 meters. What velocity is the ride traveling when it reaches the bottom of this straight drop? All right, let's write down what we know. We know delta x is going to be negative 30 meters. We know it's free fall, so acceleration is negative 9.8 meters per second squared. We don't know anything about time. We want to know what is the final velocity. And we know that the initial velocity is equal to 0. So it didn't have any velocity at the beginning. So that would be equation number 2. The final velocity squared is equal to the initial velocity squared plus 2 times acceleration times displacement. So final velocity squared is equal to 0. Plus 2 times negative 9.8 meters per second squared times negative 30 meters. Let's put that in your calculator. Velocity squared is equal to 588 meters squared per second squared. Let's take the square root of that. And that would be 24.25 meters per second. However, what's wrong with this answer? All right, it's going down. We've got to make it negative. So negative 24.25 meters per second. So if it's going in the downward direction, this particular equation forces you to choose your sign because it's always going to give you a positive answer. All right, make any corrections if you need to, and let's do number 7. Okay, number 7 says that a physics student drops a rock off of a cliff, takes the rock 3.5 seconds to reach the bottom of the cliff. How tall is the cliff in meters? Okay, we know time, 3.5 seconds. We know acceleration, we're in meters, so negative 9.8 meters per second squared. Our goal is to find how tall is the cliff, so we want to know delta x. The initial velocity, the student doesn't throw the rock down, just drops it. So the initial velocity is 0. So this would be equation 3. So delta x is equal to v naught t, initial velocity times time plus 1/2 at squared. So delta x is going to be equal to 0, right? This goes to 0, plus 1/2 times negative 9.8 times 3.5 seconds, and don't forget to square that. So delta x is negative 60 meters. But we don't report heights of something as negative. That was just the displacement of the rock, so our height is equal to 60 meters. Height is just going to be the positive of the displacement. All right, I think I can get number 8 on this board. So number 8 says a parachutist falls from a plane for 5 seconds before opening the parachute. How fast is he traveling when he opens the parachute? All right, well, I'm going to work this one in meters. If you worked it in feet, of course, you'd use a different acceleration, but time is equal to 5 seconds. Of course, we're neglecting air resistance in this case. Our acceleration's negative 9.8. We want to know how fast is he traveling. So that's the final velocity. When we know that initial velocity is equal to 0, we're assuming that the plane is traveling horizontally. Okay, again, we have time, acceleration. We want to know final velocity. So in this particular case, we could use equation 1 even. So let's go ahead and use that. So that would be velocity is equal to initial velocity plus acceleration times time. All right, so our final velocity is equal to 0 plus negative 9.8 times 5 seconds. It's a little under 50, right? Negative 49, and it makes sense that it's negative because we're going down. So negative 49 meters per second, moving pretty good after 5 seconds. Of course, it wouldn't really be quite that fast due to air resistance. All right, make corrections if you need to, and let's finish this thing out with number 9 and number 10. All right, number 9 says, a child throws a ball up in the air with an initial velocity of 3.9 meters per second. What's the maximum height the ball reaches? All right, so you got to remember that max height occurs when the velocity is equal to 0. So we know our velocity. Okay, the initial velocity, v naught, is 3.9 meters per second. And we know this is a free fall problem, so acceleration is negative 9.8 meters per second squared. And we want to know the maximum height, that's displacement. Okay, we don't know anything about time. So but we do have enough information to plug all this into equation number 2. So that's velocity squared is equal to initial velocity squared plus 2 times acceleration times delta x. All right, our final velocity is going to be 0 at max height, and we'd have 3.9 meters per second plus 2 times negative 9.8, and then we're solving for delta x. All right, so that's going to be, this is 3.9 squared is 15.21. So we have 0 is equal to 15.21 plus, so I'm going to go, that's going to be negative, so minus 19.6 meters per second squared times delta x. All right, so that's going to end up being, if we solve for delta x, we'll move that 15.21 to the left and make it negative. And then divide that by negative 19.6. So again, we're sliding this 15.21 over, making it negative, and then bringing that negative 19.6 underneath. That gives us a positive displacement, which makes sense because the child's throwing the ball up in the air. of 0.78 meters. So the child is not able to get a whole lot of juice on that ball because it didn't go up very high. It's just a little under 3 feet. All right, so that is number 9, and let's finish this homework assignment out with number 10. Number 10 says a physics student stands on a ladder 12 feet above the ground, throws a ball up in the air. If it takes the ball 4.2 seconds to hit the ground, what's the ball's initial velocity? Okay, so if the ladder is 12 feet, so here's the ground, got a ladder. The ladder is 12 feet. So the ball does go up some amount, it comes back down, but the displacement is really just from where it started to where it finished. So displacement is negative 12 feet. Since we're in feet, we know acceleration is negative 32 feet per second squared. Be careful to watch your units and not put negative 9.8 there. We know that time is 4.2 seconds. And we want to know the initial velocity. All right, well, the equation that has all of these variables in it is equation number 3. That's delta x is equal to v naught t plus 1/2 at squared. Okay, so we're going to have negative 12 is equal to v naught times 4.2 seconds plus 1/2 times negative 32 times 4.2 seconds, and I don't really have room there to put the unit squared. All right, so sorry about all that smushing. 1/2 times negative 32 times 4.2 seconds squared. Okay, so we would have negative 12, I'll move over a little bit here, is equal to 4.2 times v naught. And then when you multiply out 1/2 times negative 32 times 4.2 squared, you get 282.24. And that is about 32. I'm sorry about that. That's feet. So that's going to be the seconds and seconds squared would cancel. Second squared and second squared, so you'd have feet left here. All right, so we would have, we're going to add 282.24 to both sides, so that'd be 270.24 equals 4.2 times v naught. So v naught is equal to 270.24 feet. And that's why I keep writing down all the units, because you know you end up with the right units here. 4.2 seconds. We want an answer that's in feet per second, so we didn't really mess up any of the algebra here, doesn't look like. And that's 64.3 feet per second. All right, I really enjoy these problems. I hope you do too. Hope you made corrections anywhere that you need to. And next step, we'll be doing the lab and then on to the extra practice problems. So talk to you next video.